Well, hey, cool cats and kittens. It's May the 6th, and it's time to move on. We've been talking about animals, and of course, animals don't exist in a vacuum. They exist with other things, and we're going to talk about the interactions between animals and their environment. That's going to be kind of our culminating study here as we move on towards the Regents, which is now only 5 weeks away. It's coming up. Hope you're not too nervous. There's a lot of pressure on you.
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
Ecology. Ecology, what a great word. It's this from the Greek word oikos, eco, which is Greek for house, and ology, which is Greek for to study. It's the study of one's house. Now, we're not going to go and study your home. We're going to study our house as a species, which happens to be this great planet, planet Earth. So ecology covers all kinds of things. It's like interactions between organisms and relationships and patterns of development and all kinds of things like that we need to know to understand our place on Earth as living things. So you look forward to studying ecology. Now, the first thing we need to learn is that organisms in their environment are affected by a couple of things. There are some non-living things that have a big effect. We call those abiotic. That's a word you'll need to know. Abiotic, not living, never was living things. Right? For example, water is a big one. Water is really important. The ability of the abundance of water really determines what organisms can live in a certain place and how many can live there. Right? Water's not living. Water's not even organic. Water's H2O, right? It's an inorganic molecule. Right? So the amount of water, which can be like the amount of precipitation and the amount of water available, is a huge factor. Temperature is another huge factor. We know that temperature affects the ability of enzymes to work. And so temperature is really a big factor in who can live where and how long they can survive in those places. So I would be remiss if we wouldn't talk about soil and sunlight, especially for the producers or for the plants that live in a place. That's essential, right? They've got to have quality soil and they have to have the right amount of sunlight. So these together, taken together, we call the abiotic factors. Abiotic. And then of course, there are living things, biotic factors, like what kind of producers, what kind of plants are available in the area for you to live? What are some other consumers that are hanging out? Do you have competition for resources? Are you being preyed upon? Or are you a predator looking for certain things? Or maybe a combination of both, right? And then what happens to bodies when they die, right? What do the decomposers do? So we've got some, what we call the living things, the things that are living factors in an environment, we call the biotic factors. These even are things that were once living, like dead, decaying plants and dead, decaying animals and those kinds of things. Those still are biotic because they are once living. Right? So we have abiotic factors, not living, biotic factors, living. Biotic and abiotic. Biotic and abiotic. You're going to need to know the difference between the two, and you're going to need to know some examples of each. Then when we think about like our environment, right, we think about how it's organized, right? And usually when we're talking about environments, we're talking about ecosystems, all the plants and animals and all the abiotic factors, right? But we do some other organizing. If you take a step back and you just look at the living things in an ecosystem, we call that a community. A community is just the living things in the system. And if you look at the living things, you take a step back and you just look at one kind of living thing, one species, we call that a population, right? One species is a population. And if you take a step back, just look at one individual from a population, we call that, of course, an individual, right? So layers of organization. We'll usually be talking in this class about populations of individuals, communities of organisms, and ecosystems. And then we'll even spend some time talking about these large areas on the planet that have similar ecosystems called biomes. Biomes. You probably have heard of those at one point in your life. All right, so we're going to need to know the levels of organization of ecosystems, right? That's what you're going to need to know. And then one thing we know, without limits on populations, right? Populations will grow over time. That is, more individuals will be added and added and added as organisms reproduce, right? If they reproduce faster than they die, will go up, okay? If they reproduce at the same rate as they die, there won't be any change. And if they die at a greater rate than they reproduce, the populations go down and eventually go extinct. All right, so what we know about populations is in various ecosystem, usually populations can go up to a certain point. The ecosystem has what's called a carrying capacity. Carrying capacity is like the greatest number of individuals that ecosystem can support before there's a population crash. Carrying capacity, right? The maximum. You can go over the carrying capacity, but usually it'll self-correct and you'll drop down beneath the carrying capacity. And we'll do some activities where we'll study carrying capacity as well, right? Like fish in a fish bowl. How many can fit are not necessarily how many can survive. Yeah, super brief introduction to ecology, our next real unit of study here. We've got lots of fun things to look at for sure when it comes to ecology, and maybe we'll get to spend some time outside. I don't know, we'll see how that goes. Hopefully the weather will cooperate. Anyway, let's finish today's Bellringer. And you've got a head puzzle, got some notes on ecology today. All right.